usual example of parametric equations where we need to get a Cartesian equation are these as follows. Why is it unusual? Because we're not so familiar with dealing with a triple angle, sine 3t. We know sine 2t, cos 2t, double angle work has a very big part of the A-level course. But dealing with sine 3t or cos 3t is something that doesn't come up a huge amount. So for this example, if you follow the way that I've been doing the other conversions from Cartesian to parametric, we need to isolate the trigonometric functions. So we've got sine 3t, sine t, but there's that third in the way. So let's just bring that across. So we have 3 multiplied by 3. 3x is sine t, and y is sine 3t. And usually what happens now is you have to find an identity that connects sine 3t to sine t. Now you are not expected to go into the exam knowing what formula breaks sine 3t down to sine t. However, you are expected to be able to derive the formula. They don't expect you to memorize it off by heart, but you are expected to be able to derive it. So, how do we deal with sine 3t? So the trick is to write sine 3t as sine 2t plus t. Then use the expansion formula for sine a plus b, which is sine 2t cos t plus cos 2t sine t. Now you may ask yourself, well, this was sine 3t, we're looking to break it down in terms of sine t, and this looks a little bit of a mess. So then, why do we have an expression like this that will help us? Because now we have double angles. Double angles we are happy with. We have formulae for those. We know how to break down double angle. So you might ask at this stage, why am I not using sine of 1.5t and cos of 1.5t? Or cos of 0.1t and 1.9t? So you can use any two angles that add up to 3t, but there's no point using those random angles that I just suggested, because when you get sine of 0.9t, then what? Well, there's not a lot you can do with that. If you have 2t, well, then the double angles I can work with. We know what they break down to. And also, you want t there, because ultimately I want to break it down to sine t so that I can connect that. So anyway, sine 2t is easy. There's only one formula. There's only one formula for sine 2t, which is 2 sine times cos. So we have 2 sine t cos t, that's sine 2t. Then we're multiplying by another cos, so that becomes cos squared. Now, cos 2t has 3 potential formulae. Cos squared minus sine squared, 2 cos squared minus 1, 1 minus 2 sine squared. Stop the video and have a think which one of the formulae I would want to use in this scenario. So hopefully you would have realised, because the goal is to break this down in terms of sine t, I want the formula that has sine in it. The formula for cos 2t in terms of sine only is 1 minus 2 sine squared. So, let's use that one there. It's starting to take shape. Notice the expression that I've got for sine 3t has almost all of it, sine, 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 almost all of it is in terms of sine. There's just one anomaly, which is the cos squared. How am I going to get rid of cos squared? I'll write it as 1 minus sine squared. So that's the next thing to do. 2 sine t, brackets 1 minus sine squared. I'll actually multiply this out. 1 times sine t minus 2 sine cubed t. Multiply this out, and we're almost there. 2 sine t minus 2 sine cubed t plus sine t minus 2 sine cubed t. Finally, collect like terms. 2 sine t and another sine t makes 3 sine t, minus 2 sine cubed minus another 2 sine cubed makes minus 4 sine cubed t. Notice we haven't finished the problem. We've just spent a reasonably long time deriving a formula that converts sine 3t in terms of sine t. We're now going to use this formula and finish off the actual question. So, we've now derived that sine 3t is 3 sine t minus 4 sine cubed t. We can finish the problem off. Sine 3t is just y. Sine t is 3x, therefore you've got 3 multiplied by 3x. Sine cubed, well I know sine cubed is just the cube of sine t. Just be careful, you've got to cube the whole thing. So it's 4, the cube is on the sine only, it's not on the 4. So it's multiplied by 3x cubed. That becomes 9x minus 4 times 3 cubed. That's 4 times 27. That's 108. That is a Cartesian equation. Very often in an exam question they will ask you to factorize it. So you notice, what can we take out? 9 and 108. Well, 9 goes into 108, so we can take out a 9. X and x cubed, we can take out an x. So the final answer would be this. That is your Cartesian equation. But very important derivation we've learnt here, how to deal with sine 3t in terms of sine t. This question is good for parametrics, but it's also good for other parts of trigonometry. If ever you need to deal with sine 3t, you're probably going to have to go through this process. As an exercise, you can also derive a formula for cos 3t in terms of cos only. Perhaps you'd like to have a go at that as well.